Okay, so let's look at these second order differential equations that are of this form. So you've just got a y double dash minus some constant of y dash minus some constant of y. If they're in this form, what we do, we just change it to a quadratic equation basically. So lambda squared minus 3 lambda minus 4 equals 0. And we solve that for lambda. Now, when we solve that for lambda, this one's nice and easy. It just becomes two numbers that multiply together give minus 4, add together they give minus 3. So that's obviously lambda minus 4 and lambda plus 1. Therefore, lambda equals 4 or minus 1. This is the first case where we've got real roots. So we've got two real roots. That's important because that's the first case. When we get two real roots, our general solution just becomes C1 e to the 4x plus C2 e to the minus 1x. Let's write minus 1x. And this 4 is just coming straight from here, and this minus 1 is coming straight from there. And that is our solution if it's a homogeneous equation. And that's really all it is. So it's a nice, simple way to do it. These are the easiest, I guess, of the second order differential equations. The next thing that can happen is if we have something like this, y double dash plus 6y dash minus 9y equals 0. What we get here is we get equal roots. So this one we get equal roots. So our solution to this could be, at first, we might think it's going to be C1e to the 3x plus C2e to the 3x. But really what this is exactly the same solution written twice, and we want two solutions. So when we get equal roots, we have to put an x in there, and that gives us linearly independent roots suddenly, because these two solutions are now linearly independent because we put that x there in this case. So that's the second type, when we've got equal roots. And the third type is if we get complex roots. So in this case, we've got complex roots. We've gone down here. We've solved that. We couldn't solve it. We used the formula and we found that our roots were 3 plus or minus 2i. So our solution in this case is going to be C1e to the 3x, the 3 straight from here, sine 2x plus C2 e to the 3x cos 2x. And again, this 2 is coming from here. And that's basically, this is if we get unreal roots or imaginary roots, or complex roots is probably the best way to put them. Complex roots. And that's really the three examples to start with, and the three different types of things you can get. Okay? Hope that helps.